Hi, this video is a supplement to the article I've written about depth first traversal, so you can refer to that article. And in this video, I just provide a very gentle introduction to depth first traversal, what we are trying to achieve here. I hope you have seen the video I uploaded for breadth first traversal. That's another way to traverse a graph. So I'll just give you a quick recap of what breadth first traversal is and how this one differs from BFT. So in breadth first traversal, we saw that suppose this is a graph I have. Okay. So in BFT, I'm referring to breadth first traversal as BFT. I'll traverse the root node first, suppose Ankur, and then I traverse the adjacent nodes to this node, that is Reena and Dikshit here in this graph, and then I continue to traverse various levels. Okay, so it's like level wise traversal, level 0, level 1, level 2, and so on. So if you think of a tree which has a root, then children, and then each of its child nodes has in turn got children. So you are traversing the root, then children, then its children, and so on. Now, compared to that, depth first traversal is slightly different. In this traversal, we are trying to go to the depth of a particular node. What I mean is, so suppose I start with Ankur in depth first traversal. I'll start with Ankur, then I go to Reena, who is connected to Ankur, and then I explore the adjacent vertex to Reena, which is Nidhi. So in breadth first traversal, I was doing Ankur, Reena, Dikshit. Okay, but here I'm doing Ankur, Reena, Nidhi. So it's like you're traversing this whole path basically from root to one of its leaves. Okay, as far as you can go. So it covers the entire depth, then it comes back, then explores the next vertex, goes to the depth of that one, and then it continues like that. It's like a recursive approach to traversal. So, in a nutshell, that is how it differs to BFT. This finds application in topological sorting. So, if you are familiar with directed acyclic graph, um, then directed acyclic graph can be traversed using topological sorting. Topological sorting is like ordering a list of vertices, say on a straight line. So it has got to do with the ordering of resources or vertices. So I'll talk about that in another video. For now, let's look at the program that can be used to perform DFT. So if you see this program, I mean, this is a C program for DFT. You can find the link to the code underneath the video. So if you see this method, DFS method, it's trying to traverse basically the same graph, and we initially pass the starting vertex, which is Ankur here. Okay, so this is passed as a parameter to this graph, and then we check whether it's visited or not. So if it's visited, well and good, we return. If it's not, then we try to check its adjacent vertices. Okay, if you see here, I'm doing Q and next. So this is the pointer stuff basically. So we are trying to traverse the list corresponding to the vertex that we have, since we have a adjacency list for the graph. So we try to see which is the adjacent vertex. So in our case, it'll be say Reena. Okay, so it picks up Reena and then it performs DFS on Reena. So this is like a recursive solution. So it goes to Reena, then it goes to Nidhi, and then it returns basically and starts from the next adjacent one, which is Dikshit. This is a pretty straightforward program. Just take a look. I think you should easily be able to understand this one. And that's pretty much about depth first traversal. The application part, like I told you, topological sorting. Another thing is like you can put time against traversal. So time at which we visit this node, time at which we visit this node, and what time it ends. So once we know the starting time and the end times for traversing a particular vertex, that can be used to derive a lot of information, like who is an ancestor to a particular node, and various kinds of relations can be derived. So, but on a simpler level, this is a very brief introduction. I hope you guys get some clarity about this. You can read the blog for more details. Thanks.